Hello everyone, welcome to watch our video. We are going today to revise for semester 2 exam. Let's begin with the first question in the final revision sheet. Okay, find the open intervals on which the function f of x equal 1 over x squared is increasing or decreasing. As you see, that is the given answer, but I'd like to show you how we get this answer. Look here, we have two ways to solve this one, graphically or analytically. Way one, I will use the graph of this function or the sketch of this function as we learned it before. I know the sketch of this function looks like this one. Okay, here it is going in two quarters, quarter one and quarter two. As you see here, that is the domain. Negative infinity, that is what? Infinity. 0. As x increase, y increase. So the function here in this part is increasing. In this part, as x increase, y what? Decrease. So the function here on this interval decrease. At 0, the function n and define. That is why at x equals 0, divide the domain of this function into two intervals, negative infinity to 0 and 0 to infinity. So f of x is increasing, okay, on this interval, negative infinity and negative infinity to 0. F of x is decreasing, okay, on the interval what? 0 to infinity. If you remember the sketch of this function as I showed you before in quarter 2, it's okay. But if you don't remember the sketch of this function, I told the steps as Step number 1, I have to find the first derivative. Number 2, I have to find the critical number. Part 3, the first derivative. First what? Derivative. As you know, when we are talking about the interval in which the function is increasing or decreasing, we use the first what? Derivative test. Okay. As you know, to find the interval of this function, I need to rewrite the function first, which will be x to the power negative 2. Just move the variable to the numerator with negative exponent. To find the derivative, it will be negative 2 x to the power negative 3. You have to remember the rule of differentiation. So it will be negative 2 over x to the power 3. But I forgot to tell you something. Before I find the derivative or the critical number, I have to know what is the domain. Here, the domain, all of the values of x except x equals 0, because at 0, the function undefined. And as you know, the critical number must be values of x at which the function defined first must be the function defined as if the first derivative equals 0 or does not. So in this case, to find the critical number, here I don't have any values of x at which the numerator equals, that is the numerator and that is the denominator. Okay. The first derivative equals 0 if the numerator equals 0, but here the numerator negative 2. Negative 2 impossible to be 0, so we don't have critical number at which the first derivative equals 0. Okay, here first derivative, okay, does not exist when x cubed equal 0 implies x equal what? 0. I show you all the details. But as you know, 0 not included in the domain, so there is no critical number. We don't have critical number. No critical what? Number. Okay, to draw this one for the first derivative, as you know, from negative infinity to infinity, we put on the first derivative line, this as you see, the values of x at which is a function undefined because it will divide the domain into intervals and the critical number. But here, as you see, we have only values at which is a function undefined. We don't have critical number. Test value, I use that test value. As you know, we have a relationship between the sign of the first derivative and the behavior of the function, okay? This value, we call it test value. I use this value here, which is what any values included in this interval. I choose -1, which included. Here I choose 1. Then I have to replace in what? In that first derivative. Know the sign of it. I don't care about that value. Negative, negative, it will be positive. Since the first derivative positive, the function is increasing, as we know from the theorem. 1, it will be negative, replaced in the first derivative. Since the first derivative negative, so the function is what? Decreasing. So here, increasing in what? Increasing on negative infinity to 0, decrease on what? 0 to infinity. That is our answer. But I have to show you how we get this answer. Okay, let's solve the next problem. Find the open interval on which this function is increasing or decreasing. Okay, here I can decide what is the stage of this function, but I know I can draw it, but okay, no problem, follow the steps. It's easier for you to follow the step 1, find the first derivative. Here, increasing or decreasing first derivative. Okay, first derivative here, it will be what? 3x squared minus 6. Okay, second step, I have to find that critical number. You have to know the domain here of any polynomial function or real number. Okay, here I have to find the values at which the first derivative equals 0. I don't have values of x at which the derivative does not exist because it is a polynomial. 3x squared minus 6x equals 0. Implies fx 3x as a common factor, it will be x plus, okay, minus 2 will be 0. Implies here x equals 0 from the first factor, or x equal what? 2. Short step, I have to draw a line for first derivative. Okay, here that is the line, first derivative. I substitute in the first derivative. What are the critical numbers 0 and 2? Both of them included already in the domain. 0 and 2. Here, negative infinity, and here what? Infinity. Test value, as you know, here it will be -1. Here I can choose 1. Here I can choose 3. Where we will replace by the test value, we will replace in the first derivative. Okay, it will be here. If we replace, find the value, it will be -3. You can use your calculator. -3 multiply -3, it will be positive. I care about the sign. So the behavior of the function is increasing, as we know. If we replace by 1, it's here 1 positive, this one negative, it will be negative. So the function is what? Decrease. Replace by 3 in the function, I care about the sign. It will be positive. So the function is increasing. As the theorem, according to the theorem, we have a relationship between the behavior of the function and the sign of the function. So in this case, f of x is increasing into interval which are what? Negative infinity to 0 and what? 2 to infinity, as in the given answer. That is the answer key, but you have to show me your steps from where we get it. Okay, f of x is decreasing. Okay, on which interval? From 0 to 2, as in our answer. I think it's so easy. I just follow the steps. According to the sign of the first derivative, I can identify the behavior of the function. Let's solve the third equation in page 1 in the revision. I know that is the answer, but you have to show me how we get it. Why we choose this answer? Find the values of x that give relative extrema for this function. By the same way, since we are talking about relative extrema or critical number or increasing, decreasing, I'm talking about first derivative. Okay, we have to follow the steps. The first step, as you know, it will be for derivative 15 x our domain. You have to know what is the domain, all real numbers, to power 4 minus 15 x to power 2. That is the first step. Second step, perhaps we find the critical number since it is the first derivative, it is what polynomial. So I find only the values at which the first derivative equals 0. It is not rational, okay? Equals 0. By the same way, take 15x squared as a common factor, it will be x to the power 2 minus 1 equals 0. Okay? That is gives me what equals to what x equals 0, or x squared minus 1 equals 0 implies x squared equals 1, x equals positive or negative 1. Here I have how many critical numbers? 3 questions. So draw the line for the first derivative, as you know. Sorry. Okay. Wait a minute. Here. Okay. Now, write what I will put the critical number on the line and the values of x at which the function undefined, but this function defined for all x here from negative infinity, and here what? Infinity. Here negative 1 from the smallest to the greatest, 0, 1. Test value. I think all of us remember this one that we learned in course 3. It will be negative 2, negative 0.5. Here 0.5, and here I take 2. Replace in the first derivative to identify this. Look here, not at every critical number we have extrema. To have extrema at the critical number, the behavior of the function must be changed. Must be changed. Replace by negative 2 in the derivative here, or here by any way you can use your calculator. This one it will be positive, this one positive, it will be greater, it will be positive. So the behavior of the function is increasing. Negative 0.0, it will be here negative. So the behavior of the function, by using the calculator, find the value and take the sign. It will be half, it will be also decreasing. Actually, if we replace in the first derivative, as you see, it will be positive. Okay, if here positive, so the function is increasing. At this critical number, negative 1, we have extrema. But since the behavior of the function changes from increase 2 degrees, so we have what? Relative maximum. Okay? Here at the critical number 0, the behavior of the function does not change. No extrema. Because I told you, the critical number at which the function must be defined, the first property. Second one, the first derivative equals 0 or does not exist. Third one, the behavior of the function must be changed. But here, there is no change in the behavior of the function. It means decrease, decrease. But at this critical number 1, here from decrease to increase, in this case, we have relative minimum. So as you know, we have a relative maximum at negative 1, relative minimum at x equal 1. That is why our choice is B. If you remember, when the function is increasing, when the function is decreasing, okay, what is the meaning of relative extrema? How we find the critical number? If we find this one too. Okay, let's solve the page 2. Here, find the interval on which the graph of function f of x to the power 4 minus 4 x to the power 3 plus 2 is concave upwards or concave downwards. Then find all points of inflection for the function. Look here, concavity, so I'm talking about second derivative, not the first. That is the answer, but I have to show you what is the answer of this one or how we get it. Okay, first step, I have to find the first derivative. To find the second derivative, already I have to find the first derivative. I don't care about the critical number in this case. Okay, as you know, we have a relationship between the concavity and the sign of the second derivative. If the second derivative positive, more than 0, so the function concave upward. And in this case, we have relative minimum. If the second derivative less than 0, so the curve of the function concave downward. That is according to the theorem. And in this case, we have a relative maximum. You have to remember this theorem. Here, the first derivative will be 4 x to the power 3 minus 12 x to the power 2. And as you know, the derivative of any constant. Please keep the rules of differentiation with you when you are studying, when you are revising, okay? Watching the videos, keep it with you. The rules of differentiation and the rules of integration. To find the second here, second derivative, it will be 12x squared minus 24x. Third step, I have to find when the second derivative is 0 or does not exist. But please be careful. 12x squared minus 24x, it will be 0, implies take 12 as a common factor, x will be x minus 2, okay, equals 0. I know all of you know how to factorize and solve this equation. Okay, it will be x equals 0 from the first factor, or x equal what? 2. Maybe at x equals 0 and x equals 2, we have inflection point. But when at any one of them, we or both, we have inflection point if the function changes its concavity. Changes what? Its concavity. Okay, here, draw a line. But this line for what? For the second derivative. Okay, write the values at which the second derivative equals 0 or does not exist. Here, 0 and 2. Maybe inflection, maybe not, maybe both. I don't know. That is what we will see. This value, as we did with first derivative, I will do with the second derivative. Here it will be -1, here 1, 3. I replace in what? In the second derivative. I have to replace here. Okay, it will be positive. Since the second derivative positive, so the function concave downward from -infinity to 0. Okay, downward. So sorry, upward. What is it saying? Okay, positive, upward. Positive would be what? Upward. I'm so sorry. At 1, if we replace at 1, it will be negative. Negative downward. Okay, at 3, it will be positive. It will be what? Positive. Just replace in this way. It will be positive. According, that is the value of the second derivative. Okay. So the function concave upward. In this case, I will write what f of x is concave upward. Okay, on which interval? From -infinity to 0 and from 2 to infinity. F of x is concave downward. Okay, on which interval? Here from 0 to 2. At the values of x equals 0 and 2, the function changes its concavity at the beginning. At 2 and 0 and 2, the function defined, yes, since the domain of this function all real numbers. Second step, at 0 and 2, the second derivative equals 0. Third step, at x and 2, the function changes its concavity. At 0, from upward to downward. At 2, from downward to upward. Since at this value of x equals 0 and 2, the function changes its concavity, so both of them are critical as them. the function has inflection point. So inflection point, the inflection, okay, points are what? 0 and f of 0. Because since it's only points, it means x and y. X and y, x coordinate and y coordinate as the order of the pair. And what? 2 and f of 2. You have to replace in the original function to find the y coordinate. So it will be 0 and 2. If you replace 0, 0, 0, it will be 2. You have to find the y coordinate. I have to replace in the original function. And 2, negative 14. F of 2, it means the negative 14. Just replace here and use your calculator to find the. Okay, so trivial and very interesting lesson. Okay, for this one, find given that f of x equal negative f over x, choose the correct answer. I told you before, I have two ways. I can sketch the function. I know what is the sketch of this function. Yes, you showed me before. If you would like to know what is the sketch of irrational function as this one, here it has the vertical asymptote at x equal what? 0. It is drawing in second, and here since all of the given here are all of the given is talking about the concavity. So okay, I have to describe the concavity or find the interval in which the function concave upwards or down. From negative infinity to 0, the function concave upwards, here downward. Here the graph is concave upward on the interval 0, no, downward. That's right, wrong. Concave upwards on the interval negative, yes, that is why our choice. That is if you would like to choose to use the sketch of the function. It's so easier for you. But some of you told me before, Miss, I don't know the sketch of this function, or I can't know this, how to use the graph of the sketch to find the interval. Okay, but anyway, I follow the steps, which are here first derivative, second one, second derivative. Okay, third step, find when the second derivative 0 or does not exist. But here the domain equal what? Sorry, all x except x equal what? 0. Here I need to realize the function to be in the simplest form. I think all of us know how to realize that. What is the first derivative? It will be 8x to the power negative 2. How to find the second derivative? It will be negative 16x to the power negative 3. We write to be in the simplest form x to the power 3. Here, second derivative does not exist when the denominator equal what? 0, because impossible denominator be 0. That's why we don't have zeros of the second derivative as I showed. Implies x equal what? 0. But it is not included in the domain, so we don't have inflection point. Okay, we don't have inflection. Here, fourth step, use what? Second derivative. I told you on the second derivative test, in the second derivative test, we put in the line the values at which the function undefined, or the first derivative equals 0, that is in the first derivative test. But here in the second derivative, I put the values at which the function undefined, or the second derivative equals 0 or does not exist. Okay, I write here 0, that is from negative infinity, that is from infinity, a test value. Any values included in this interval. Okay, negative 1, I replace in the second derivative. As you know, it will be positive. It means concave upward. Second derivative positive, concave upward. Okay. 1, it will be negative, concave downward. That is the second derivative, as I showed you. So the function concave upward on this interval. That is why our choice is C. But I prefer to use the sketch of this function. It will be easier for you. I know the sketch of this one. Okay, I hope you understand. Let's solve the next problem. Give the sign of the second derivative of f as the indicated point. So yes, here at this point, the curve of the function was concave upward. I have a relationship between the concavity and the sign of the second derivative. Concave upward, it means more than zero, it means positive. Okay, that is why our choice is the B. Okay, thank you for joining this session. Study well to be ready for the exam. Bye bye.